Hello all and welcome back to this fundamentals of computer networking session. In this class we will understand IP conflict. What is IP conflict? See, usually if you see, when you give same IP address, two computers in the same LAN, same network, so two computers will fight each other to get that IP address, to have that IP address. That is called IP conflict. See, the magic thing is you have one computer in the network called VM1. The IP address assigned is 10.0.0.1 10. So you have one more computer in the same network. When you have different IP, okay, nothing will happen. If you give the same IP, what happens? This computer will say some message. In earlier, in Windows XP we used to get a message called IP conflict message. Nowadays most of the computers is not getting that kind of message, pop-up message, but we used to get in earlier days in our old operating systems. So two computers will not have the same IP address in the network. How this computer knows this VM1 has already this IP address? Someone has to do the job, no? So who is that someone? How that IP conflict will happen? Who helps to resolve, not to identify the IP conflict? Who helps to identify the IP address? For that I need a small setup, like having 2 or 3 VMs. Let me go to my VM setup. I'm in VM1. I started this VM just now. I will log in to this VM. I will log in all the other computers. I need only 2 computers, enough. So I have computer 2, VM12 and VM1. I will go to VM1. I think you remember we have installed a Wireshark in this. In this system only we installed a Wireshark. If it is not there, then I have to install. I am installing Wireshark now, so this will take some time. I will pause the video till that. Once the Wireshark is ready, then I will continue. If you want to know how to install Wireshark, you can check our previous classes in the same playlist. You can find the installation process of Wireshark and how to install and other things. So now I have successfully installed a Wireshark. I will open Wireshark. It's loading. Now Wireshark is ready, up and running. Let me check the IP address first. What IP address I have? I will go to command prompt. IP config. I will have 10.0.0.10 IP address. Okay, fine. And let me check the other computer VM IP address, which is VM2. I don't require Wireshark here because this is just a PC computer 10.20. So what I will do is I will go to VM1 again. Under VM1 in command prompt I will try pinging to 10.0.0.20. so it should get response, and I will be able to see the ARP request and response message. Here ARP request response and ICMP request reply. This we known to that in last class we understood all this, right? Very well. But what I am trying to show you, what happens when we conflict, when IP conflict happens. So what I will do is I will clear the screen. I will go to nicard ncpa.cpl. let me do one thing. I will start capture. While capture is going on, I will try to assign a new IP. So which means we have to know what happens in the backend when you try to configure an IP address. So for that, what I will do, I will go to IP. Instead of giving 10, I will give 100. Okay, 100. When I click OK, see, let's come here. I think we have to say further close. See, there is some traffic generated. I stop. You see, listen. You see here, ARP. After that only IGMP came. After that NBMS, NetBIOS name service came. MD, Microsoft domain name system, all came. But what is going to happen when you give an IP address? That's the main thing. Understand carefully. Let me show you in this picture. When you try to give, or when you try to assign 10.0.100 IP address, this computer immediately send ARP request. Okay, this computer immediately, see, not only Windows computer, you give IP address to any computer, any OS, doesn't matter. ARP request will be originated from that computer if the computer is connected to the network. It is shouting. What is shouting? Boss, let me show that. Who has 10.0.0.100? What it's saying, ARP resolution, sender's IP address, target address. See, that computer is shouting in the network, boss, I am going to assign 10.0.0.100. This is my MAC address. Is anybody here with the same IP address in the LAN? This is what the announcement, broadcasting. ARP sending a broadcast message to every computer in the LAN saying, boss, I am this so and so MAC address. I will be configured with this 10.0.100 IP. Is anybody there with this same IP? Nobody has responded. Why? Because ARP request went, there is no ARP response. Why? Because no computer having this 10.0.0.100 IP address. That's why nobody has responded. That's why this computer decided to have this IP address and get configured this IP address called ipconfig. If you see here, ipconfig, you will see 10.0.100. You got it? Let's see one more IP. I stopped capture again, close without saving. I will go to network. See in the back end, 10.0.200. 200. Nobody is there with 200. Click OK. Click close. When you click close, no, immediately this computer will generate ARP. Check. See what happens? Immediately ARP generated, ARP originated, sending. Leave about all the other protocols, NB, NS, IGMP. This is all different topic. Leave it. Is anybody having 200 shouting 3 times? No, then it announced that, which means it says, boss, nobody has responded me back with the 10.0.200, so I myself configured this IP address. This is happening in the backend when you configure IP address. Usually what we do, we don't know nothing, no, we just take IP, okay, close, done, okay, over. But this is what happens in the background. If you see the thumbnail, no, what I have given the title of this class is who helped or who help to conflict IP address, to avoid conflicts. This is what, no, understand ARP, how ARP resolves IP conflict. Okay, now let's see. I will stop capture again. I will start capture again without saving. I will go back. Now you see the magic. I'll go to properties. This time I will say 20. Why? Because 20 already there in the same LAN, same computer, same network. Okay, I say click OK, close. What happens? There is no broadcast sending. There is no broadcast. What happened? See, I stop. When the ARP request went for taking 10.0.20 IP address, immediately ARP respond came, boss, 10.20, I am there at 002. Who is 02 here? Who is 02? Would you like to check? Go to VM2, get MAC. Who is 02? MAC address 0402. Whose MAC address? Second VM's MAC address. So second VM's response back immediately, hello, hold on, who are you? I am already having this IP address 10.20. see, this is my MAC address. This IP address back binded, which means it conflicted. IP got conflicts. There is no, this computer will not have this IP address 10.20. That's why this computer got automatic private IP. Okay, automatic. It is APIPA. We used to call it APIPA, automatic private IP address. It didn't take 10.20. It took automatic private IP. Once it took automatic private IP, so then again ARP sending a broadcast to take this IP address, MAC, this automatic private IP. You understand? So who helps to resolve IP conflict? ARP. Actually, who identifies IP conflict in network? ARP. ARP is the one who identifies IP conflicts and tells this is what happens when you use Wireshark. No, then only you will identify what happened in the background. That's why most of the network people, most of the firewall people, most of the security people, no, they will use these monitoring tools, analyzing tools to identify what happens in the background. This is very important one. This is what the topic for today's class. We connect next class for understanding we understood ping process, we understood the ARP conflict, and we have to understand some routing table, routes, different networks, communication. We will see in the next class. See you. Thank you. Bye.